Well, hello. Today is October 15th, 2024. This is SIG Node weekly meeting. Welcome, everybody. We have a few items on the agenda. First item is from me. I was reviewing some promotion to GA caps, and we have a couple of them. And we have this new requirement that we have emulated version support in API server for 3 versions. So 3 versions ahead, meaning that 135 will be able to emulate 132. Yeah, I think that's right. So and this is done by keeping the feature gated code for 3 more versions. And it's mostly applicable to API server. So for Kubelet, we don't have this requirement. So Kubelet will never be running in the simulated version. But the question arises, what do we do with graduated code? So in the past, with graduated code in Kubelet side, we would just remove everything under featuregate and lock featuregate to default. And we can continue doing that. However, we have the problem of we need to do this for Kubelet, but for API server logic and for some other components, we need to make sure that we are not breaking emulated mode. So we need to keep the logic around. And I was trying to gauge some feedback on whether we want to keep that code around in Kubelet as well, just to make sure that reviews go in easier. So we don't need to go deep into details like whether it's Kubelet only code or it's not Kubelet only code, or we just so we can, option 1 is to follow what the API server is doing and keep the dead code around. And option 2 is selectively remove code from Kubelet and keep code on API server. Is there any opinions?
Why do you want to keep the code which is consuming the memory and not doing anything good?
Yeah, the only motivation for me is simplifying life. So we, instead of reviewing carefully and understanding whether it's Kubelet only code, we just keep everything around, and then 3 releases later we just remove it altogether. So yeah, my only motivation is to simplify reviews and minimize the number of errors.
From my side, in an ideal world, I would go with on a case-by-case scenario, and okay, this can remove this, or can. But we are not in abundance of engineering power, so the simplest and safest option seems to be, to me, what Sergey is proposing. And I have a question though. There is any guidance requirement suggestion in the CAP about the kubelet? Because this seems like a great example, a great point to make about emulating version. Is any guidance from the CAP? I didn't review it yet.
CAP is explicitly saying that kubelet is out of scope.
Okay. So the proposal we are discussing is just to be nicer. Let's say just in big quotes, to be nicer, to make things easier, and it's not a requirement.
Yeah, so we don't need our code around. But
okay.
Practically, it's not trivial to distinguish which one is only Kubelet and which one is not. Okay, you had a hand?
Yeah, I mean, I guess the reason why, I mean, I guess Sergey brought it up on my PR, what kind of impacts us is unit testing around feature gates. Because like, I guess originally when I would promote something stable, I would remove the tests that are actually testing the false feature gate. It seems like that needs to be changed to use this emulated feature gate mode. And also the other question I have is around end-to-end tests, specifically node ETE, because like we do set feature gates on kubelet, and I think that we have to remove those if we promote the stable, and we can't really use emulator mode. I guess that's probably okay.
Yeah, so my understanding that CAP was advocating for running previous, like same way as we run like 130 tests, like subset of all the test lane for 130. They will be running like subset of all the tests for 131 in emulated mode of 130 with 130 kubelet. That is my understanding how testing is supposed to be going end to end. So from kubelet side, we don't need to test that. But from E2E of disabling feature gate, I think you are right. We will end up rewriting all the disablement of feature gate into like emulating the previous version. I really want to get some guidance from people who created this. Maybe they can give more guidance there.
Yeah, I mean, yeah, I don't know like what we have in SIG Node to really enable that anytime soon. Like I don't know how much we are actually changing or setting options on the API server. But I guess what sort of this impacts are features that like I'm imagining like user namespaces or something that actually has like a pod spec API, which like or DRA where those are impacting the pod API. And then those we'd have to obey the emulator mode, right? If we have like some kind of API in the pod spec or anything.
Right. It's a actually good point. We need to start writing these questions down. We only have 1 month for code freeze and without any instructions and any test infrastructure in place. And you are right. And to E2E would be easier to implement, but we know it will be quite hard. We don't have any support for that there. So yeah, maybe we need to bring it up to SIG and
yeah, let's take it to SIG and yeah.
But what I'm here is there is no strong objections of like just keeping code around, just to simplify reviews. Okay, I see nodes, at least one. Next topic is from Chris. Please take it away.
Sounds good. Hi, everyone. My name is Chris, and I'm an engineer on the GK Node team. So a month or so ago, Don put out a proposal on some potential enhancements to Kubernetes to support dynamic batch workloads. And this included things like improving support for containers that are dynamically scheduled across a set of worker pods, and for also improving pod resource management to support these workload types. So in an effort to show off how this could work, I put together a prototype of a set of custom resource definitions and a controller that could facilitate scheduling these workloads. I'm wondering, Sergey, would it be possible for me to share my screen? I don't know if I have access to that.
You are co-host to be able to.
Oh, I am. Oh, perfect. Okay, let me go here then. So let's double check this is on. People can see. Can people see my screen? Hopefully, the GitHub. Yep. Yes. No. Yeah. Okay. Cool.
You may want to just zoom in a bit.
Sure. Sorry, my bad. Let me. How's that? So yeah, this repo is linked inside the meeting note docs, and it's public. Everyone can go take a look. But this demo is heavily inspired by many of the design concepts used by Ray and their white paper. But the solution basically introduces 3 new custom resources: tasks, task objects, and task clusters. Tasks are essentially lightweight functions that run in a task cluster and perform some work. Task objects are the input arguments for these tasks. And then the task clusters are just the worker pods that these run on. And lastly, we have this thing called the task controller, which is it's a component that's just responsible for managing the life cycle of these tasks in task clusters and performs the task scheduling. So let me see, where is this? Where did I leave off in my notes? So under the hood, a task is essentially an ephemeral container that runs on a worker pod in the task cluster. And task cluster is just a wrapper around a deployment. I put together a small and simple demo of how this could work with a counter task. So This counter takes as input a task object that contains both a count and a limit. And then when the task runs, it reads its definition and its input task object from the Kubernetes API, parses this task object to extract its arguments, checks if the current count is equal to the limit, and if not, then it recreates itself and spawns a downstream task with an updated count. So just to keep things interesting, I thought, why not do a live demo just for fun? And let me share that tab or that window. Where is it? Okay. Can people see my terminal? Cool.
Yes.
Okay. So what we have here, these three tmux panes are basically watching three task cluster worker pods. If I back out real quick, you can see these three are just worker pods, and they're just responsible for running these tasks. And what I'm going to do here is I'm going to run this script, and it's going to create the 0th task that starts out with count equal to 0. And once it runs, you'll see here, it's going to start creating these ephemeral containers and randomly schedule them across these worker pods. And each time one of these containers runs, it receives a new task object and performs the work of basically checking, has the count reached the limit, and if not, trigger a new task with a new task object. And this will continue running until it reaches 50, which should hopefully be soon. I have a script here also as part of it, just called verify.sh. And basically what it does is it looks at the 0th task object that was initially supplied and then the very last task object, just so we can make sure that it actually incremented it 50 times. And I'll run that. We can see the initial task object count was 0, and now the final count is 50. So that's a very simple demo, but I'm sure this could be extended to do something more complex in the future. I think, let me reshare this other tab. Sorry, let me go back to my window. Sorry, 1 second here. Let's see. So there's a couple of known limitations about this that I just want to say. It's since it's a simple demo, I mean, obviously it's not going to be perfect, but adding support for more complex data types, because currently the task object spec is it's basically just kind of like a config map. It's a map of string to string, and we would need to figure out how to add support for more complex object types that we might want to pass around. And then the other thing is, if we run these tasks as ephemeral containers, you can add ephemeral containers to pods, but you can't remove them. And so what ends up happening is the pod spec just grows and grows and grows over time. And I think that'll potentially lead to some scalability issue eventually. So if we needed to make any downstream changes or upstream changes in Kubernetes, that may be one of them, would be adding support for moving them. And I think with frameworks like Ray and other dynamic batch workload frameworks, I think a lot of the value add would be in providing libraries to abstract away the complexity of creating tasks, fetching the input task arguments, and then serializing them back to a task, creating downstream tasks, and all of the interactions with the Kubernetes API. So just me speculating how this could potentially look in the future, maybe Kubernetes would provide a set of easy APIs like or libraries for abstracting away some of these complexities, so application developers can just focus on their application code. But that's essentially it. And if you have any questions, please let me know. Otherwise, feel free to open any pull requests, or if you want to make any changes or fork it, be my guest. That's it.
I think Francesco's hand was probably first.
Okay.
Hey, hello. Thanks for the demo. Nice. About the ephemeral containers which makes the pod spec grows. I have a question, so pardon me because I didn't read the spec or the proposal, so probably you already answered that. But I mean, the worker pod which hosts the ephemeral container, are they special in any way or just, stateless pods to host the function? Because if so, maybe, just maybe, we can, when the pod reach a size limit, so like it's 100 ephemeral or whatever, kill it and replace it with a new replica. I mean, is that feasible or ruled out for some reason? Thank you.
No. I think that is feasible. So to answer your first question, I don't think there's anything special about these pods. They're just regular pods, and they just have one pause container just to keep it open. Other than that, I don't see why the task controller couldn't watch for pod, like the task controller already watches for pod updates. And so it could respond to it, see, hey, it's reached some threshold, kill the pod, and then any new tasks will just get scheduled on the current pods plus whatever new replacement pod gets created. So that's totally feasible.
Yeah, I'm just mentioning that, and I'm done, by the way. Not because I'm not against removing the ephemeral. In principle, I'm not objecting. I'm just saying this way you can probably move forward without depending by that feature in order to move forward, as I understand. So, but
Got
if we want to talk about the ephemeral container removal, I don't have any immediate reaction or negativity towards that. Thank you very much.
Okay. Yeah. I don't know who had their hand raised next, so.
I guess I think it was me. So typically when I see elasticity in most frameworks, people kind of go with changing the replicas. Like I know for index jobs, we have people the ability to change parallelism and completions. I think Ray probably has something similar. Why would one, like, I'm just trying to understand, like, for people building this, like, why would you want to add containers to an existing pod versus scaling up or down the replicas of a workload?
That's a good question. My understanding, and Don, maybe feel free to chime in here, but I think potentially adding new containers to existing pods may have some resource usage benefits, particularly for these workloads, and may potentially be faster than spinning up an entire pod from scratch.
So,
Yes, go ahead.
Chris, if I could just chime in. Yeah, I mean, I think that exactly what you said is part of it. Like the reason I had raised my hand, and sorry, I'm jumping the line, Sergey, but it's related to specifically this point, is one of the things we can do with this kind of thing is if there are GPUs and say you need to load a large model into the memory of that GPU, but they're shared across tasks, they can be attached to that pause container. And then through DRA, you can actually share that GPU with preloaded model among those new containers that get added. You could do that with a new pod too, because DRA allows you to share across pods, but I think it would be more, I think it would be lower latency to do it with containers, but that's kind of to be seen. Like I think there's some experimentation needed there.
Yeah, I wanted to add also from a telecom perspective, there is value. So it's something that I know use cases that we would like to have. What actually you're speaking about for telecom.
Yeah, I think for Ray or other framework, there's also requirements to actually share memory, and that's much easier to do it within the pod than between the pods. So there is the efficiency and how the data sharing model that is more suitable for this kind of model.
Okay, that makes sense. Thanks, everyone.
I think Sergey, we should probably waiting for that.
Yeah, I guess I'm next. So yeah, one of the questions was about sharing that Yuji already covered, but maybe we can speak a little bit more of what kind of requirements we may have for sharing between containers. And John already talked about devices sharing, so it's another thing. I wanted to ask about controller and speed of round. So today we have So today we have this like my understanding is that how implemented is some controller outside the pod that is like neither Kubernetes scheduler nor pod itself. Checking the status of ephemeral container jobs or tasks, and then also looking at like when it needs to schedule something, it goes through API server to create this ephemeral container. Do you have some estimations of overhead of this round tripping? Because it feels to be quite heavy.
Yeah, I don't have any like concrete data, but I will say like when I do run this counter demo and it's like just counting from 0 to 50, it does feel fairly slow. So I would say the overhead introduced by everything you just mentioned is significant, and is like a big room for improvement. Yeah.
My question is mostly not how to improve it, but architecturally, are we doing it right by making it outside of pod? Maybe pod itself needs to be scheduling its own tasks, and then it will speed up things.
I see.
Anyway,
Yeah.
and if you can
Yeah.
speak about a little bit about sharing of memory or whatever else needs to be shared between pods or containers in the pod.
Yeah, I think that largely depends on what you're trying to achieve. So I think in Ray's use case, for example, I think memory sharing is used in order to perform kind of like some scheduling optimizations, rather than, for example, write objects back to their object storage there at etcd. They'll just share memory and just spawn a new process on like the same worker pod. So that's kind of their use case for sharing memory. I just thought, you know, in Kubernetes land, I'm just going to let Kube API server handle everything. So no memory sharing involved. However, if we want to make some like optimizations to scheduling this and potentially like passing objects between tasks, then I think that might be a strong use case for memory sharing.
Thank you, Don. You next.
So memory share definitely can support, right? So there are TempFS and the share memory, so definitely can support. It's just in current demo, thanks to Chris to create this demo and to see the potential, so people have the visualize this code potential. The proposal, there's the several reasons, right? So the proposal I inspired by, because I heard, I talked to some folks, and we spend the time to build up the Kubernetes to make sure we can run on top of the Kubernetes. But then I heard their problem is most on the task scheduling. And at Mike, I saw you say the task is container. Yes, in Kubernetes concept, that's the container. But in those batch framework, batch distributed batch framework, they always call the task scheduling. So that I look into some other thing, and they all have that their task scheduling, how they are going to utilize the finer grain of the resource control concept, and they always identify some scheduling friction from the Kubernetes or other scheduling, even like the old time and the Mesos scheduling, because they want more finer control on the resource. And then after I studied more of those kind of the batch workload, I realized actually each one of them, they have different type of the dependency. So like, for example, if you really look at the Ray offer, they have the several offer, right, based on the different type of the workload. They're all batch workload, but they have the different type. The reason it is they want to carefully consider of the dependency, careful component of the resource sharing, resource utilization. So this is why I think about as the Kubernetes, if we want to inspired by last year, since I'm the one of this, we need to expand it to workload, support more workload. So then I think about we should give the space to the different type of the workload, to lead, especially on the how enable better of the finer grant of the control for the scheduling and for resource assignment, all those kind of things. So that's kind of a motivation original we have. And we are using informal because it's already been there. And also we think about the pod resizing and also pod resource limit for all the other use cases actually fit very well on top of Kubernetes to enable this feature. So this is a kind I can think about, this is perfect timing to send this proposal and out. So that's just give a little bit background and explain why there's the motivation behind. Mostly it's just make sure enable of the Kubernetes can evolve to support more workload. And each different type of the workload, batch workload especially, they can describe what's their dependency, what it is their life cycle for each one of them. Then we can control rest of the stuff, right? So like underneath the stuff.
Thanks, Don. So I think you answered my question. So this will have a dependency on the pod level resources, right? Otherwise, yeah, okay. Makes sense. All right, folks, any more questions?
Thank you, Chris. Very nice demo. I think next topic is from Peter.
Hey, everyone. So a little bit of background. We were planning on pushing forward for swap GA in 132, and then there were concerns that came up around integrating changes in the eviction manager to better sort of handle swap. And so we've decided to retarget to beta in 132 and add support for evictions, like a preliminary one before pushing forward for GA. And I wanted to bring up potential option to do that, a way to do that, and discuss that if since we have a bit of time. So share my screen. I've drawn this drawing about an idea that we're currently working on. Basically, so the way that eviction works today, you can look at this right-hand side. We have the total memory, and that total usable memory is the qubit will wait for there to be a percentage of that total usable memory hit before it starts triggering evictions, and then it'll sort the pods based on memory usage compared to their limit, and then evict pods. The proposal that we've been thinking of basically creates a new sort of way of thinking about memory in the kubelet, where the memory is sort of accounted both for swap and memory, but specifically when you count swap, we can't really count the full swap space. When a pod is allocated swap based on the ratio of its memory limit to the total memory limit, and that is applied against the total swap amount, because we assume that system services aren't using swap, and also any pods that aren't burstable aren't using swap. So all of the swap available on the node is presumably available just for the burstable pods. So and the pods basically get a little slice of that memory of that swap, depending on the ratio of their memory to the total memory. So the proposal is basically to treat the amount of swap that is actively in use by burstable pods as the swap node allocatable, because that is if you think about the theoretical amount of memory that the memory plus swap that the node could use, it would be the maximum amount of swap in the node allocatable plus the maximum amount of swap that each of the burstable pods used and then have their memory swapped out to. And then when we think about the eviction threshold that would then be applied against that amount, you can think of that as the total usable memory, which is swap node allocatable plus memory node allocatable, and then that's the total usable, and then the percentage of that that is defined in the configuration, and that percentage would be the threshold at which the qubit's okay, my pod's memory and plus swap is getting to a certain point, I think it's time to start evicting. So that's basically the proposal as is. And I just wanted to see what folks thought of this. Yeah. Sergey.
Do you suggest we have any way to understand, like, what would be the way to prioritize which pods go next, like being evicted first? Is it by total memory with swap, or is it by
Yeah, that's a good question. I mean, I think the ideal would be, I haven't quite gotten to that point yet. So far, just gotten to the point of like understanding when Kubelet is actually evicting, but I think I would have to look in deeper into the current eviction algorithm and then try to apply it to this. I would imagine you would have to treat the burstable pods as basically having this extended swap amount as their like total memory limit when like looking at the amount of usable memory. But that may like weigh heavier towards evicting burstable pods, which might be the right thing to do. So I'm not totally sure. I'm open to suggestions if you have an idea.
Yeah, that's a problem. I don't have very strong idea, and I didn't think about it very extensively so far. And another question is, how does it depend on swappiness factor? Like, if swappiness is, I don't remember which one is better, high or low. Like, if swappiness says that don't swap proactively, then we can end up with very empty swap if all the memory being used all the time. Will eviction kick in this case? Like, how do we detect the case when kernel just doesn't want to swap because memory is being used all the time?
Yeah, I mean, I think the lower the swappiness, the higher the likelihood that the kernel will have to step in and kill, because like it's like that basically sets the amount of swap, like a percentage of swap max as the like actual amount that's going to be used. So I think I'm going to guess that in the process of defining these eviction thresholds, we're also going to have like come along with recommended swappiness amounts. I don't know if the first iteration will be able to fully account for swappiness in the algorithm, but that would be a good thing to do, or it's a good thing to call out. But because like, you know, imagine a low swappiness on the kernel's level, but all of the memory is used up. The kernel will still end up swapping eventually. Like it ultimately will do that. It's just like how aggressive it will be in swapping versus like other ways of reclaiming memory, from my understanding. So I would still expect this swap max to be able to be fully used, even if the swappiness value is low. But I might be wrong about that.
Yeah, I guess the one, I know Peter, you and I have talked about this offline a little bit. My one thing I'm going to ask this group is like, I'm worried about the UX for like how users are going to be able to figure out like eviction based off of excess swap or memory. And like, I was kind of leaning towards the idea of having like a separate signal for swap. Like once swap is run out, we can kind of take a separate approach than we would with memory pressure. And like, I'm just wondering, like, are we okay with like kind of conflating memory pressure to mean both swap and memory are at capacity and we take the same action with regards to both?
I want to separate. I do think what we should introduce a swap, separate swap signal. But when the node and the memory pressure, you need to consider both, right? We need to clearly define priority. We need to consider of the swap signal first. Like you define something like the swap threshold, right? So eviction threshold. We need to clearly define it as which signal take first, and also for the swap. You reach off the status threshold, because the candidate will be evicted also is different, right? So you are evicted a certain workload end of the swap device, and then you basically have the impact on both memory and swap threshold. And so
yeah, okay.
So we need to define that priority. I'm open for how we are going to define that, but I do think about we need a separate signal. And the candidate also, because all the running workload based on the priority, based on the quality of the services, they are going to be candidate, right? So there could be candidate. But the swap is not all the container, all the workload will be candidate. So we need to define which one it is. Most likely the swap signal will be prioritized to consider, right? So in these cases, but logically, I think. So because once you evict, if to prevent a node get into the sysroom and prevent, because we basically mostly from a node stability perspective. And then when we consider those kind of things, we need to consider of
Okay.
Yeah.
So the last thing is, do we think we should go with having like a swap memory pressure set on the node object? Or do we kind of want, like, we don't think we need to have that much detail? Like, we have the swap signal. Do we want to say like a node swap pressure kind of a thing as a physical separate resource?
I can't think maybe we need, because that's give us flexibility. But I believe you have the more experience doing that stress test, right? So we talk about the stress test on Monday. So maybe we can come back. But so far, at least doing the CAP review for the eviction manager involvement, I'm thinking about maybe we need that separate of the swap. Allocatable or swap or threshold, something like that, to make that swap signal more meaningful here.
Okay. Sorry, Mernal, you have your hand up.
Yeah, I think like while we I appreciate all the design suggestions, I think like we'll have to go with the stress test first, right? Like we don't want to be in a situation like memory QoS, where I think we did great work, but I think it doesn't work out in practice. So we start from stress test, and then we see which design actually works to keep the node stable, right? Because we don't want to design something, code it, and then, oh, this actually didn't work out as expected because kernel is working in a fashion we didn't take into account. So maybe I think we design some stress tests like burstable pods using a lot of swap, and then how do we keep the node kubelet in the runtime stable and still functioning when that happens, and I take it from there.
Okay, so I mean, I think that sounds good. That's what we'll do in the short term, is come up with some test cases and figure out some options. And yeah, I guess we're trying to think of timeline, if there was any possibility of having this change added in 1.32. But I feel like with the eviction signal as an option, which seems to be people are liking that a little bit more, we would probably want an API change for swap evictions. So I'll focus on testing for this now, and then you can come up with some options.
Yeah, I guess like it still stays beta, right? So I think we are open to getting something added if we are able to prove that it is a step in the right direction, right?
It depends on if we have to add an API to like the node spec. I think we would have to, that would probably have to go alpha. And that's kind of what we were trying to get away.
Yeah.
We were trying to, like, I think it just depends on what kind of API changes. We were thinking that maybe for this CAP, we could get away with it without having to do an API change. But if swap signals might be the best path forward, we probably will have to consider an API change for at least evictions and potentially for a node spec, if we want memory swap pressure to be separate from memory pressure. So what I'll do for the swap cap is I'm updating it now to try to reflect what we've discussed, and then I luckily have a Vagrant VM like I set up to actually test some of this, so I will try and get like quick development examples of how I can actually test these ideas. It's I think I thought it was pretty easy to at least get ohm kills with swap on a very small node, but I have to get it up and running again. Peter, does that sound good to you?
Yep. Yeah, I mean, definitely if we want to start with the testing, that's a great first step. And we can sort of discuss what we can get in for 132 as we do, you know. My priority here is to sort of try to reduce the timeline to GA as much as possible, but while also making sure that we're keeping the users safe and sort of stable. So if we need to be more deliberate about it and go slower, it's the way it is. But, you know, I just want to make sure we're making progress.
Yep,
cool.
I agree.
If we cannot GA, maybe we can mark another beta 3 or something like that. At least there's the new milestone. I want people to feel there's the new progress, right? The features more stable and more useful. So welcome. So at least we can welcome people to try to use and test and give us the feedback more.
Cool. Alrighty. That's it for that. Unless anyone had any other thoughts.
Okay, if there are any more topics, please speak up. If not, then we have 14 minutes back. Thank you, everybody. Have a great rest of your day.
Thank
Thank
you.
you. Bye-bye.